Alright, so there are no new vocabulary words today. You know them all by now. Remember in the last video I told you I messed up. So it should be 15.5 angle relationships in circles today. This one is blank, and this is on 131. Okay. So sorry about that mess up, but right, 15.5 angle measures in relationships, and then angle relationships in circles. I don't know what I'm saying. And then turn, and let's label 15.5 in our notebook. So 15.5 angle relationships in circles. I'm going to go ahead and glue in the foldable, and then we're going to start with it. Okay, so your foldable, you're going to fold it in half. I'm going to cut so it's got 3 flaps, and I'm going to make sure I cut from the inside because I messed this one up and forgot. Cut from the inside because actually you're going to cut the word theorem in half on accident. So see, you got the theorem in half on accident. Whoops, oh well. Alright, so we're going to glue that in on page 131, and then we'll get started on the actual examples. Okay, there we go. So let's get started on intersecting chord angle measure theorem.
Okay. Number 4. First I'm looking for LKI. LKI is this right here. What arc goes with LKI? $188. Is that all? Plus this 50. That's a major arc. KHI. What is 188 plus 50? 2 what? 238. What is LKI compared to that? What is half of 238? 1 what? 19. Okay, I couldn't hear. That air cutting on and off makes me not be able to hear anything. Alright, and then how about IJ? If I highlight it, then it's like the whole thing there. This piece right here. Okay. 2 times 46. That's going to tell us this whole thing right here, right? HJ? Okay, so 2 times 46, 102, is this whole piece right here. And you guys said we subtract 50? Where in the world did I get 100 into? Thank you. 92. 92 minus 50 is? It wasn't going to make sense that it would be larger anyway. But, you know, we've seen some that's really not drawn to scale. So 42. You can find all the way around the circle because of that. Because there's how many degrees in that circle? 360. Alright, last we've got tangent, segment, exterior angle measure theorem. This is the one that has 3 pictures. But they all have the same thing going on. Not the same thing, but I mean, it's all going to be the same relationship. Here's what I mean. Like I said, if I need to give you tape yours back together in a second, I will. If a tangent and a secant, 2 tangents, or 2 tangents intersect, 2 secants. So if you have a secant and a tangent, 2 tangents, or 2 secants. If they intersect on the exterior of a circle, then the measure of the angle formed is half the difference of the measures of its intersected arcs. Here's all that's saying. Each of these angles, 1, 2, and 3, all of those are the exterior angles, are equal to half of the large arc. Usually it's a major arc, but not always. Minus the small It's not necessarily that it's always large minus small. The idea, though, is that it's the one further away. It will actually be larger minus smaller, but that's what all these are saying. The exterior angle, we can write that, exterior equals 1/2 large minus small. That's what every single one of these is. There is something nice, though, about the tangent, because how many degrees are there all the way around? Which means if you know this one, but you don't know this one, could you find it? You just subtract from 360. Okay. Which will help us on number 5. We have one of each of these. Number 5 is the tangent. Okay. So, I need to find x. I know the smaller arc. I don't know the larger arc, but how am I going to be able to find it? What is 360 minus 116? Make sure I wrote that right, because you know how it is these days. Okay, so my formula says this x is equal to 1/2 large minus small. What is 244 minus 116? $128. See, death again. 128. 88 doesn't make sense. What is half of 128? 64. Do the other two of those, 6 and 7. Some of you have already done, I know, but. Alright, this time we are looking for YUV. You can't just say U. YUV. YUV is what compared to 68 and 94? I just highlighted that in the wrong color. This is supposed to be yellow, pink. Okay. Set up, it's 1/2 68 plus 94. What is 68 plus 94? 162. What is half of 162? Okay. That is the intersecting chords angle measure theorem. And there's that again if you didn't get that. 2 secants are chords intersecting. Alright, next we're going to talk about the tangent secant interior angle measure theorem. Even though there are like 3 tabs or 3 flaps here, 3 different theorems, there are actually 5 different pictures. Most of them are half, though, of something. Either half the sum or half the difference. So let's talk about tangent secant interior angle measure theorem. If a tangent and a secant, or a chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. Here's that picture. This angle, ABC, right there, is equal to half of the arc that it intercepts. Here's the arc. So this angle is equal to half of the arc. So number 3. ABE is what we're looking for. ABE, right here. ABE is equal to what? Half of 128. What is half of 128? 64, you said? Okay. How about when we have to do it the other way? The arc CE. C to E is equal to what compared to its angle? It's twice. What angle does it go with? 68, which is CED. Yeah. What is 68 doubled? 136. Yeah, that is the same relationship as an inscribed angle. Yes. Alright, I want you guys to try number 4. In case you cannot see, the arc H to K is 188 degrees. The angle HJM is 46 degrees. And HI, just this part right here, is 50. What did you guys set up to find number 6? 173 minus 79. What is 173 minus 79? 1 what? 94. 94 in half? Okay. 1/2 minus 23, and that is 90. What is 1/2 of 90? 45. Okay, good. Glue this in.